primary goal of a business is to maximize profit. There are all sorts of reasons that a business might exist, and many of them have some very good goals in addition to this. But in order for a business to survive, it has to fulfill this basic criteria. It needs to be making a profit, and ideally, if you want to have the best sort of business, you want to be making the most profit you can. This doesn't necessarily mean charging exorbitant amounts of money. In fact, very often, reducing the price ends up being the best way to make money. We have to remember that profit and maximizing profit is not the same as maximizing income. You may feel like to get the most profit, the best way to do that is to get more money in, but that doesn't necessarily lead to a greater profit. If it also requires you to increase the costs, it may have the opposite effect. So there's two different things you want to be aware of. Maximizing revenue doesn't necessarily maximize profit. Minimizing costs also seems like it's a good idea, but that doesn't necessarily maximize profit. And the reason is, when you maximize revenue, you often increase the costs. And if you try to minimize your costs, you often reduce the revenue. And it's not either of these things on their own that we care about, it's the gap between the two. Here's a few examples that will hopefully make it a bit clearer. Option A, you have a revenue of 2,000 and costs of 1,900. Option B, your revenue is quite a bit smaller and your costs are quite a bit smaller as well. With option C, the revenue is lower still and the costs are lower still. So if you wanted to maximize your revenue, you'd probably go with option A. If you wanted to minimize your costs, you'd probably go with option C. But the thing we really care about is neither the revenue nor the costs directly. What we care about is the link between the two. What we need to look at to make the best decision is how much profit we would make in each case. So for option A, you get £2,000 in, but you spent £1,900. So your profit is £100. For option B, you don't get as much in, but your costs were lower as well. And in fact, by going from A to B, you've reduced the amount of money coming in, but you've reduced the costs, the money going out, even more. So you end up with a larger profit. You get a £200 profit. So you might be thinking, well, let's keep going. Why stop at 1,000? Why not drop things even further? We can reduce the costs all the way down to £200 if we go to option C. The problem with that is that you reduce the revenue down from 1,000 to 100. And that means that you end up with a negative profit. You would either report this as a profit of negative 100, or you might say it's a loss of £100. What it means is you've spent more money than you earned. So clearly option C is a bad choice. Option A is a reasonable choice in the sense that you still make profit, so your business is working, it's functioning, and it's doing what it should. But option B is a better choice because you make more profit. There are three fundamental rules or formulae that govern the link between profit, revenue, costs, price, and quantity. These are really important ideas. They're fundamental to the process we're going to follow here. And you need to make sure you remember them, you can accurately recall them and write them down when needed, and that you understand how they work and why they work. The first one is profit. We've talked about profit. We already recognize, hopefully, that profit is calculated simply by working out how much money came in and working out how much money went out. If you have a revenue of 1,000 and costs of 800, then you have a profit of 200. We use the Greek letter pi to represent profit here. That's just because we don't have another letter P that we can use. A little p and a big P look pretty much the same. And I don't want to reuse P because we already have that reserved for price. And price is going to come into these formulae. Price is one of the things that's going to link together with the other bits. And in fact, the aim of this whole process is to end up with some direct connection between the price, which we can mess with and tweak, and the profit, which we're interested in maximizing. So at the end, we'll have a formula that has the profit pi in terms of the price p. The next part is revenue. And this is a relatively straightforward calculation once you understand what price and quantity refer to. So price is the amount you charge for one item, and quantity is the total number of items that you manage to sell. So if you decide to sell bottles of water, and you charge £2 for a bottle and you sell 10 bottles, your revenue is £20. That's how much money you got by selling the water bottles. Costs is a little more complicated because there are two different aspects to this. With most business models, when you calculate how much it costs you to make and sell something, the simplest way to make sense of that is in terms of a fixed cost, which is something which you will have to pay even if you don't sell anything, and the variable cost, which is associated with the items that you're selling. If you sell lots of them, then you'll have a greater total variable cost. The variable cost per unit is what this V represents in this formula. So a quick reminder, the price and the quantity we've come across before. We use a demand function to link the two because quantity will change depending on what the price is set to. If you charge a lower price, you'll sell more. If you charge a higher price, you'll sell less. And then the fixed costs. This is essentially how much it costs you to run the business, even if you don't sell anything. For instance, it might be the rent. If you have a shop, you're going to need to pay rent, even if nobody comes in and buys anything from you. The variable costs are the ones that will go up when you sell more things, and they'll go down if you sell fewer things, and they'll drop to zero if you sell nothing. So if you run a coffee shop and the country is shut down so you can no longer sell coffee, during the following month you will still need to pay rent for your shop, so that's your fixed cost. It doesn't matter that you've not sold any coffee, you still need to pay the rent for your shop, but you won't need to pay the variable costs for each cup of coffee that you produce. If it costs you 50p for the coffee beans and the electricity for the machines and all the other costs associated with the materials and the labor that goes into making a cup of coffee, you won't need to pay that 50p if you're not making any coffee. So the total cost will increase the more things you make and sell, but the fixed cost will always be there. So there's a minimum to the total cost. The total cost will always have a minimum value of F, and then it will increase as you sell more things. We'll see how that affects things when we get to the graph at the end. So let's work through an example and see what this looks like in practice. There's quite a few steps to this, so I'm going to take it slow and hopefully we'll be able to make sense of each piece as it comes along. A business owner is trying to determine the optimal price to set for his product. What that means is we need to find the best price to set in order to do what businesses always want to do, to maximize the profit. Now you'll notice that there's some additional information that's given to you here. It is assumed that Q plus 250p equals 1,000, where Q is the quantity sold per day and P is the price. They've given us the demand function. That means we know how the quantity sold and the price charged are connected to each other, and we can make use of that so that anything where Q appears we can deal with because we know how it links directly to P, the price. They also tell us the fixed costs are £100 a day and the variable cost per item sold is £20. So even if you sell nothing, you'll have costs of £100 for your day. And if you sell 5 things, you'll have fixed costs of £100, but you'll also have variable cost of £20 per item for 5 items. That adds up to 20 lots of 5, £100 for the materials that you needed to sell those items. Add it to the fixed costs of 100, you'd have a total cost of 200. So let's break this apart and look in detail at each piece. The question will always give you the demand function. They will tell you the connection between Q and P, and we're going to use this along with the 3 key formulae to calculate pi, the profit, in terms of P, the price. The question also gives information about the fixed and the variable costs. This is important. They're given as a little f and a little v in the formulae, and we can replace them with these values as soon as we see them. So here's step 1. You write down the 3 standard formulae. We make a small adjustment because we know what F and V are. We're told in the question the fixed costs are £100 a day and the variable cost is £20 per item sold. So the profit formula is exactly the same, revenue minus costs. The revenue formula is exactly the same, price multiplied by quantity, but the total cost formula is going to be not F plus VQ, but 100 plus 20Q, because we now know the values of F and V. The next step, we copy down the demand function, and then we rearrange it if necessary so that we make Q the subject. What that means, making Q the subject, is that we have a formula where Q appears on the left-hand side of the equals sign, and everything else is on the right-hand side of the equals sign. In other words, if we know P, we could use the right-hand side of our formula to calculate the value of Q directly without doing any rearranging or solving afterwards. So Q plus 250p equals 1000 is taken directly from the question. When I rearrange, it just means, in this case, subtracting 250p. In some cases, there's a bit more work involved. You might need to divide by a number. If it said 2Q plus 250p equals 1000, then after you subtract the 250p, you would need to divide both sides by 2 so that you get Q equals. But once we have that, we've got something we can use to deal with the Q that appears in the 3 standard formulae on the left. So step 3, we eliminate Q. Now we know, because of step 2, that Q is equal to 1000 minus 250p. And wherever Q appears in any of these formulae, we can get rid of it. So the revenue is P times Q, the costs are 100 plus 20 times Q, and instead of writing Q, we're going to write 1000 minus 250p. I've put it in a bracket here because it's important to keep track of exactly what you have in a formula. If you leave the brackets out, you might miss terms, you might forget negative signs, and we'll see how that might cause a problem in a moment. The revenue, P times Q, becomes P times 1000 minus 250p. And now, as you can see, because Q has disappeared, we're left with an expression which only involves P. It's got a 1000p and it's got a minus 250p squared. So if I know the price, I can calculate directly the revenue. Now, you could draw a graph of that, and you could see when the revenue is at its maximum. But as we said at the beginning, it's not usually the most useful thing to know when your revenue or your turnover, your total income, is at maximum. That doesn't give you the whole picture, because just maximizing your income doesn't necessarily maximize your profit. We need to take into account the cost as well. That's where the next bit comes in. Cost is 100 plus 20Q, so I've got 100 plus 20 lots of 1000 minus 250p. And this is where the bracket comes in really useful as well. Just like with R, when you expand the bracket, P times 1000 gives you 1000p, and P times minus 250p gave us minus 250p squared. In this case, with C, 20 times 1000 will give 20,000, and 20 times minus 250p will give us minus 5000p. The last bit, I've added the 1000 and the 20,000 together, and that gives me the 20,100. So now I have R in terms of P and I have C in terms of P. R is going to be a negative quadratic and C is going to be a straight line with a negative gradient. The next step here is how we generate our profit function. This is the really useful bit. This is what the entire process has been working towards. And in a lot of questions, it will be broken down into a couple of steps. We'll ask you to calculate an expression for the total cost in terms of Q, and calculate an expression for the revenue in terms of Q perhaps, and then in terms of P, so that we can generate these values from step 3. And then finally, you'll be asked to put it together and construct a profit function. Even if this is a proof question where they say show that the profit function looks like this, you need to demonstrate clearly how you get to that point. So you use your algebra carefully, make sure there are no slips or steps. It's tempting when you get close to the end just to write the final line that you know you're expecting, but examiners will always see if you've fudged a line, particularly at the very end. So watch out for where your negatives are, make sure you're including brackets. For this final part, we're going back to the first of our 3 key formulae. The profit, pi, is given by revenue minus costs. We've now got the revenue in terms of P, and we've got the costs in terms of P. So that's what I've written out here. Looks a bit messy, but 1000p minus 250p squared, that's the revenue, R, and the cost was 20,100 minus 5,000p. And you'll notice I've put that in a bracket as well. That's really important, because if you're subtracting 20,100 and you're subtracting negative 5,000p, it's different to subtracting 20,100 and then adding minus 5,000p on the end. Taking away negative 5,000p has the effect of adding 5,000p. So the 1,000p from the beginning and the positive 5,000p from the end give us the 6,000p term in the middle here. And this is our profit function. So that's what we've been working towards. We're going to look on the next couple of slides at how we can interpret that function and get the answer we care about, the optimal price. To analyze our profit function, we're going to find our calculators really useful. The Casio ClassWiz has a mode that you can use to find the solutions to a quadratic equation and to find any maximum or minimum points on a quadratic curve. So whether or not you're comfortable dealing with quadratics in different contexts and working with them by hand, you don't need to be for this part. As long as you've got it written in the right form and you can enter the numbers in the calculator, it will do the hard work bit of that for you. And your job, as any good mathematician's job will be, is to interpret your results, make sense of them within the context, and check that they are logical. So this is how we analyze the profit function. We now have a quadratic involving p. It has a p squared term at the beginning, minus 250. It has a p term, positive 6,000, and it has a constant at the end, which is minus 20,100. I've written it in this way, with the p squared bit first and then the p bit and then the number bit, because that's the format that the calculator will look for. The calculator is expecting y equals something x squared plus something x plus something. And these three somethings are the same somethings that I've underlined. We just need to remember that on the calculator, what we're calling pi, the calculator will call y, and what we're calling p, the calculator will call x. So you enter that into the calculator's equation mode, go to menu option A, choose polynomial, and then degree 2. That means the highest power of the variable that appears is a 2. We've got a p squared. That's what makes it a degree 2 polynomial, or a quadratic as we would call it. And you press equals, it will show you a number of things. It will show you the roots of the curve. That means the x coordinates, or in this case the p coordinates, where the curve crosses the x-axis, or in our case crosses the p-axis. We'll see what that looks like on the graph in a second. Those I think are given as x1 and x2. When you press equals and then press equals again, you'll see the second root of your equation. And then if you continue to press equals, it'll tell you some more things about your curve. It'll show you the maximum point of the curve. It'll give you the x value and the y value that correspond to that maximum point. And in this case, we know that that means the price, p, and the profit, pi, which correspond to that maximum point. We'll get a graph that looks like this if you can draw it. Once you know where the roots are and where the maximum point is, you can sketch in the curvy shape for yourself. The roots will be the points where it crosses the x-axis, and the maximum is the highest point on the curve. And we'll be interested in both coordinates for the maximum point, the price coordinate along the bottom of the graph, and the profit coordinate, which will be up the side. Both of those you can get directly from the calculator. If you want more details of how to get that from the calculator, the link at the bottom will take you to a video that you can look up. Now I'm going to look in more detail at the graph so we can see exactly where these things come in. The graph has p on the bottom and pi up the side. That's because the price measured along the bottom is the independent variable. We get to set the price, and we're hoping that as a result of setting the price at the right thing, we get a large profit. And then all of the key features that you manage to extract from your calculator, we can see on the graph, and it's a really good place to put them so that you can make sense of what's happening. On the vertical axis, we have profit. That's the total profit we make altogether. So remember what p and pi mean. If you just remember the words price and profit, that's probably not going to be enough. You need to remember that the price is the individual price per item. So 20 represents charging £20 for each item that you sell. And the profit is the total overall profit, not just for a single item. We don't work out the profit for a single item, so we'll never be doing that in this course. We're getting the total profit that we make all together. The first thing to notice are the roots. You should have found a 4 and a 20 when you put these into your calculator. If you've not tried putting it in yet, pause, put it in the calculator. You should get x1 equals 4, x2 equals 20, or possibly the other way around. But those two numbers are the roots of your quadratic equation. They are the points where the quadratic curve crosses the x-axis. And in this case, that means the points where our quadratic curve crosses the p-axis. It tells us something really useful, because at those moments, the profit is 0. These points are called the break-even points. It's a neutral equilibrium result. Your business is making as much money as it's spending, which means it's not making a profit, but it's not making a loss either. So you could argue, well, if you've taken into account the paying the salary of your workers and of yourself as part of your costs, then a company not making a profit is not necessarily a terrible thing. It just means that the company's ticking over. They're not losing money by running the company. They're not gaining money. It just ticks over at a £0 profit. But we can see that happens at two different points. They're both break-even points. We often refer to the lower one as the minimum price for the break-even, but the upper one is a maximum price. If you try charging less than £4, you will make a loss. You can see the curve is starting to go into the negative down here. You'll make a loss because at less than £4, you're struggling to cover the costs. And you'll make a loss at the other end at more than £20 because you won't be selling enough. You sell lots and lots if you make it very cheap, but you don't get very much money to offset your costs if you have them very, very cheap. At the top end, if you make it too expensive, then you won't sell enough to offset your costs. And of course, there's the sweet spot in the middle, which is what we really care about. If we look at the very peak, we have a maximum point, and it happens when p equals 12, and it gives a pi value of just under £16,000. So what that tells us is that the optimal price to charge is £12 per item. That's the very best price, because if you charge £12, that's the right balance between selling plenty, so you still make quite a bit of money, but not having them so cheap that you're not making much money on each one. This is the sweet spot in between. And you'll notice that it's exactly in between. It's halfway between 4 and 20. So you should expect that sort of symmetry to appear. The greatest possible profit is the number we get when we put this number 12 back into this. You can get it directly from the calculator anyway. You keep pressing equals and it'll tell you the x and y coordinates of the maximum point. And that means that if you charge £12 per item, you will end up making £15,900 profit in total. If you charge a bit less than 12, you'll make a little bit less profit. Not too much less. It doesn't tail off very quickly initially. And if you charge a bit more, you'll sell fewer items, but you'll get more profit per item, which means that your overall profit is still pretty decent. But the very best you can do is charge £12 and make £15,900 profit.